Here's problem number 1215. A uniform 120-pound beam is supported in a horizontal position by a pin and cable as shown in the figure. What is the magnitude of the force by the pin on the beam? First thing we want to do is a free body diagram, and so we'll label all the external forces acting on this beam. Well, we know the beam weighs 120 pounds, so let's indicate that at its center of mass. We're going to have a tension in this cable going up at this angle here, and since this angle is 37 degrees, that would make this angle here 53 degrees. So we're going to have two components to that tension. We'll have, if I can get this, a T sine 53 degrees going up, and a T cosine 53 degrees going to the left from this point. Okay, we also have a reaction force at the pivot here. I'm just going to call that V and H for those two components. So there's our free body diagram with all the components of the forces showing. Alright, if we select two possible pivot points, either A over here or B over here. Let's calculate the torques about point A. If I'm looking at point A, I've got a T sine 53 degrees with a moment arm of 12 feet, trying to make this thing rotate counterclockwise, which would be a positive torque. I also have 120 pounds, the weight, with a moment arm of 6 feet. That's half the way there. That's trying to make this thing rotate clockwise, which would be a negative torque. All the other forces have lines of action that go through point A, and hence they have no torque about point A. So simply put, the summation of all the torques about A is equal to 0, and that's going to be equal to 12 feet times T sine 53 degrees minus 6 feet times the weight. So in other words, solving for T is going to equal 6 times the weight divided by 12 sine 53 degrees. That's going to be 6 times 120 pounds divided by 12 times the sine of 53 degrees. The 6 feet and the 12 feet have the same units, so the feet will cancel out, and so we're just going to get pounds. So this gives us 75.1 pounds. That's the tension in the cable. Nice to know, but we want to find the reaction force. Well, if I look at the summation of the forces in the x direction, that should be 0, and we have H minus T cosine 53 degrees. So H is going to equal T cosine 53 degrees. That will be 75.1 times the cosine of 53 degrees, and that is what? 45.2 pounds. If I look at the summation of the forces in the y direction, that should be equal to 0. That's equal to V plus T sine 53 degrees minus 120 pounds. So V is going to equal 120 minus 75.1 times the sine of 53 degrees, which would be 120 minus 60, or 60 pounds. Those are our two components. The magnitude of our reaction force will be equal to h squared plus v squared square root. That is going to be equal to 45.2 squared plus 60 squared square root. And that is equal to 75.1 pounds. So that's our answer for the reaction force. The magnitude of the force by the pin on the beam is 75.1 pounds. Answer.